Hello everyone, I'm Samidha Varvekar. Welcome to the session on disk structure and formats. Understanding disk structure and formats is very essential for the purpose of investigation, as it forms the base of how the data is stored, organized, and retrieved from the storage device. So, in this video, we will explore the physical characteristics of the hard disk, low-level formatting processes, different addressing schemes, and partition strategies. So each of these aspects plays an important role in how the data is managed on the disk and how the evidence can be located and analyzed. So first we'll see the introduction. Disk structure and formats are the important concepts in digital forensics as well as in computer science. They define the way in which the data is stored, organized, and retrieved on a storage device, that is a hard disk. So disk structure simply means the layout of a disk. It can be physical or logical layout. And disk format means how the disk is prepared for data storage. Next, we'll see some physical characteristics. This refer to the physical aspects of a storage device, like a hard disk. These characteristics define how the data is stored on the hard disk. So some of these characteristics are platters, tracks, sectors, cylinders, and head. We'll see this with the help of the images. So first is platters. Hard disks are composed of some individual disks, which are called as platters. As shown here, these are circular in form and the data is stored on these platters. Next is tracks. Tracks we have seen in the previous video also. So tracks are the circular rings on each platter, as shown here in this example and also here. So tracks are nothing but just the circular ring across the platter. Each track is again divided into the sector. As the roads are divided into lanes, such as in that way, tracks are divided into the sectors. And as we know, sectors are the smallest unit of data. Next is cylinder. Cylinder means the set of tracks. It is cylindrical in form. And next is head. Head. Head is the tip of the arm. It rotates across the hard disk and it is basically responsible for reading the data from the hard disk and writing the data on the hard disk. So these are all the physical characteristics of a disk. So further we'll see an example of how an image is stored on the disk. So basically when a hard disk is plugged, it starts rotating and the hard disk has an arm with the tip of the end which is called as head. So as the hard disk is rotating, the tip of that arm, that is the head, it also spins along with that disk. And it is responsible for some movement, like either it will store the data on the disk or it will read that data from the disk. So imagine that you save a picture of a cat. Then first this image is broken down into tiny pieces, means that all those pieces are saved separately on each sector. These sectors are across the tracks. As we know, track, it is a set of sector, so these sectors are stored across the track which is on the platter, and then the head rotates across the track. It locates the sector, each sector which is holding each piece of that image. Then the head will assemble each piece of that image and a whole image is displayed on the screen. So this was all about the physical characteristics of the disk. Next we'll see significance of these characteristics in digital forensics. So first is unveiling layers of data. So these characteristics serve as a base for data storage, and understanding the composition of the hard disk helps in reconstructing the data, also identifying the patterns, and in some cases it helps in recovering overwritten or deleted files. Next is tracing the digital trails. So tracks are like trails on the map. They reveal the order of the data, and also they provide the user activities. Next is pinpointing data locations. So as we know, sectors are the exact location of the data. So it allows the investigators to pinpoint the exact location of where the data is stored, and it helps in locating hidden data. Next is data recovery. Physical structure of the disk determines how the data is stored and accessed, and basically understanding this will help to recover the deleted files or damaged data. Understanding disk operations. Knowledge of disk operations can provide the information about how the data was created, modified, or deleted by the user. Next point is low-level formatting process. Low-level formatting is a process that involves creating the physical structure on a storage medium, such as hard disk or SSD, that is solid state drive. This formatting process is typically performed at the factory during the manufacturing of the storage device. So basically, at first, the hard drive is a blank, it is unusable, but we can prepare it for the data we want to store on that drive. So this preparation is known as low-level formatting. It means creating the physical structure on the disk. This process is performed at the time of manufacturing in the factory. It is also known as zero field formatting because it replaces the old data or creating it to the zero state on the disk. Purpose. The primary purpose of low-level formatting is to initialize the physical structure of the storage medium. This includes defining the tracks, sectors, and other parameters which are necessary for organizing and storing the data. So the main intention of this process is to create a foundation on that disk, which includes creating of tracks and sectors. Creation of tracks and sectors. The platter inside a hard drive is divided into the circles which are called as track, and then each track is further divided into the sectors which are known as the smallest unit of storage. Data markers. During low-level formatting, special markers are set on the disk to identify the beginning and end of each sector. During the process of low-level formatting, the surface of the hard drives are marked with markers to indicate the starting and end point of data recording block. These markers helps to read or write the heads in locating and accessing data. Bad sectors. The low-level formatting process also identify and mark any bad sector on the disk. So this process also identifies and marks some bad sectors. These are the areas which are defective and that should not be used for storage. Next is impact of low-level formatting process on data. So if the low-level formatting is done on a disk containing data on it, it will be replaced quickly by zeros and the data cannot be recovered by any recovery tool. It reduces the service life of the hard disk and may cause damage in certain conditions. So basically low-level formatting process erases the data on the disk and that data cannot be recovered using any recovery tool. So the next point is addressing schemes. Addressing schemes are the methods used by the computer's operating system to locate the data on the disk. There are two common addressing schemes: cylinder head sector addressing and logical block addressing. So these schemes are basically used to locate the data on the disk. So further we'll see types of addressing scheme. CHS, cylinder, head and sector addressing scheme. This scheme is based on three parameters, that is cylinder, head and sector. So this is the early method of giving address to each block of data on the disk. It is based on three components: cylinders, heads and sectors. So as we know, cylinders are set of tracks. Heads are located on the side of platters which are responsible for read or write of data, and sector, it is the smallest unit of data storage. So basically this addressing scheme, it doesn't work well with the modern drives. Next is LBA, logical block addressing. This is the linear addressing scheme. It assigns unique identifier to each sector on the disk, and it is used in modern hard drives. So in this method, linear way of addressing is performed. So it assigns a unique address to each block of data. We'll see this by seeing the image. So as you can see in this image, CHS addressing for each cylinder, the sector count starts from 0. For each cylinder, it starts from 0. While in LB addressing, it has only one sector counter where every sector has unique number starting from 0. So it has only one sector counter, and here all the sectors are assigned unique number which is starting from 0, and it is going in a linear fashion. So this was all about addressing schemes. Next we'll see partitioning strategies. Partitioning strategies refers to the method used to divide a physical hard disk into multiple logical storage units known as partitions. Each partition functions as a separate disk and can have its own file system. So basically partitioning means dividing the disk into logical sections, and each section is considered as single hard drive, which is known as partition. So there are basically two types of partitioning: MBR and GPT. MBR, that is master boot record. This is the oldest partitioning scheme. It supports up to 4 or 3 primary partitions. It cannot handle disks larger than 2 TB. Uses partition table located in master boot record. So MBR, that is master boot record. It is the oldest partitioning schemes. It is named after MBR boot sector, that is master boot record boot sector, which is the first sector of a hard disk. On MBR, the disk is divided into two partitions, that is primary, which is mainly of three partitions, and then extended form. The extended form is further divided into other sections, that is logical sections. MBR partitioning scheme uses MBR partition table, that is the first sector on the hard disk. Next is GPT, that is GUID partition table. This is the modern scheme which has replaced MBR in some modern hard drives. It is used in UEFI based systems, that is Unified Extensible Firmware Interface. It supports unlimited number of partition, supports disk larger than 2 TB, uses partition entries in GUID partition table. So as compared to MBR, GPT supports unlimited number of partition and the disk larger than size of 2 TB. So GUID partition table, that is globally unique identifier. This table is located on the second sector of the disk, and GPT also helps in data recovery. And UEFI, it is UEFI is basically like BIOS, that is basic input output system. So MBR is used in BIOS based systems and GPT is used in UEFI based systems. So both of these are the softwares which starts when we boot the PC or when we start the computer. So UEFI is a modern software which supports larger hard disks and it loads when the PC is started. It is just like BIOS. So far in this video, we have seen physical characteristics of disk like platters, tracks, and sectors. These all characteristics determine how the data is stored and accessed. Also, we have seen formatting process, which prepares the drive for use, addressing schemes, which helps in locating data. So each of these aspects play an important role in the data management, and it also defines how the digital evidence can be located and analyzed. Thank you.